Okay, welcome to Circuits Lab. We're going to go through our next session in circuits and we're going to talk about electromagnetism. Okay, now the entire goal here is for you guys to get a sense of similarity between magnetism and how electric fields and magnetic fields are related together. Okay, now let's talk about a simple magnet. A simple magnet, which I'm sure you guys are all familiar of, is a simple magnet. It has a pole, you have a north pole, and you have a south pole. Okay, now, the thing about the North and the South Pole is, you need to understand, number one, which direction the fields are going from the North to the South Pole. And again, we're talking about magnetic fields. Now, typically, you'll have fields that will come this way. They will always come out of the North Pole, okay? And you'll have fields that will always be going into the South Pole. So the directions are very important. Remember very quickly that the um, the sign North Pole arrows are pointing out, South Pole arrows are pointing in. Okay, so I hope that helps you. Now let's go take a look at another, completing the set of lines here. Then you have fields that go through. Um, if you can just give me one quick second, let me just add a new layer here. We have fields that go between the north and south, and the direction is still the same. They're going to come out of the North Pole, they're going to go into the South Pole. Okay, same thing here. They're going to come out of the North Pole and they're going to go into the South Pole. Okay, so that's the main crux that you guys need to understand, that magnetic fields are always coming out of the North Pole, the arrows are coming out and they're going into the South Pole. Okay, so this is an example of a how magnetic fields truly work. Okay, so this is magnetic fields. Okay, now we're going to go and take an analogy here and essentially describe to you how electric fields work. So these are magnetic fields. Now let's talk about electric fields now. Okay. Now, similar to North and South Pole, in a typical magnetic fields, you have a positive charge, and then you have an electron, which is a negative charge. Okay, and you have fields that go back and forth between the two. Now, that's no different. That the fields, electric fields, are coming out of the positive, very similar to how we had the North Pole, and they are going to come into the negative, which is similar to a South Pole. And then, of course, we'll have fields that'll go between positive and negative, and same thing, they'll come out of the positive and will go into the negative. Okay. Okay, so this gives you a sense of that this is analogous to a North Pole and this is analogous to a South Pole. Okay, so, and this is a electric field. Okay, now, and I think we'll go into the discovery here, but Maxwell and Faraday were the two critical scientists who essentially said that magnetism and electricity are tightly related into an area called electromagnetism. And let me give you guys a brief example of what they meant and what the process of discovery was. Okay, so now we're going to go through a new diagram and we're going to show you a simple rod, okay, a simple iron rod, and some of you have already done this experiment for potentially. So you have a little rod here, okay, that's a simple iron rod. So this is just a iron rod, it's no different. You can get a nail if you want to. And what we're going to do here is that we're going to loop through a wire. Let me actually try a different color. Okay, let's try a different color. So we have a wire that comes through. We coil it around the electromagnet. And we're going to connect that to a positive and negative side of a battery. Okay. Now, the moment, this experiment was done and you bring a compass, and compass is a simple instrument. You have an arrow here. An arrow always point towards the north, and that's the only arrow you need. Then the one that's further down at the bottom of the arrow is a south, and then the one to the left of it is a west, and then to the right of it is east. But the only thing you need is a compass. Okay. Um, Here, and then let's put another compass right here. So I'm going to erase that here. Um, um, but remember, this is just a simple iron rod. It's nothing, no different. is just a piece of metal, and we're going to do exactly the same thing here, where we will put a compass here, okay, with a simple north and a south and a west and an east, okay, and we're going to connect it to the battery and we'll provide some voltage to it, okay. Now at what point in time will the how will the magnets react? And basically what was discovered here, as the current is flowing through, it was figured out that and of course current is flowing this way, this way, this way, this way, this way, and then comes back here again, okay. So again, the conventional current flows from positive to the negative. um, so in this one example, what we are looking at is that the magnets are going to start moving. Okay, now we'll go into that a little bit as to where the magnets are moving, but basically you will see that this side over here will be point towards the negative, or this side would point towards the north pole, and this side will move towards the south pole. Okay, so the magnets are going to move the closer you're going to bring them towards um, the ends of the iron rod. Okay, now the moment the magnets are moving, clearly, we know that electricity is creating sort of a magnet, right? And that's what's causing these magnets to react. Okay. Now, this pole will essentially be the south pole. Okay. This essentially will be the north pole, and the needle from the north is going to move towards the south. Okay. So bottom line is that as the compasses are reacting to it, okay, we will find out that this compass here is going to move a north-south compass. Okay, is going to move so that it will show that this is a south pole. Okay, and then same thing will happen on the other side. Okay? So clearly we know that there is a direct correlation there. Now, in a few minutes, we'll sort of discover as to why, how do we figure out which side is north and which side is south. But let's just go through a couple of basic fundamentals here before we get to that point. Okay.